Hello guys, welcome back to Maths on African Motifs. Still working on our mathematics grade 10. This is one of the most important topics that we have in our syllabus, which is the Euclidean geometry. Euclidean geometry is very, very important in the simplification of many things that you're going to have. So you have to be very, very careful. You have to understand your theorems, the properties of shapes, the properties of lines. All right, so that is what you're going to have as our introduction so that you'll be able to understand whenever we shall be answering or doing question papers, you know the basics of this topic. Where is it from? And what are the aspects that you are required to understand in your syllabus? Okay, so this is the revision of lines, angles, triangles, and polygons that we shall have. So we shall be talking about the lines, the angles, triangles, and the polygons. Okay, so the first thing that we have is the line property number one. Remember, line, we're just considering a straight line. So considering a straight line, the first property that we have is that the adjacent angles on a straight line are supplementary. Supplementary, we are talking about two angles that are on a straight line adjacent to each other, this angle and this angle here being adjacent, that is, they are sitting next to each other. All right, we've got this angle and we also have this angle. They are adjacent to each other. So the concept is that we are talking about two angles. So the supplementary is that they add up to 180 degrees. That is the supplementary. Remember, we are talking about two angles adding up to 180 degrees. Two angles adding up to 180 degrees. All right, so if we consider this angle and this angle, if added together, they must give us 180 degrees. So let us take a consideration that this is A and this is B and this is the point C and we've got another point D, whatever that we have. All right, so if ABC is a straight line, then we've got another angle because B is separated into two angles. Let's say this is our B1 and this is our B2. All right, where maybe there's another point here, which is D, we can refer as ABD, the angle ABD, that way, okay? ABD, that is B or CBD, another angle. If I write this as 1 and I write this as 2, then I can have my angles as B1. So this angle is going to be referred as B1. This angle is going to be referred as B2. So that is the combination. Angle B1 plus angle B2 should give us 180 degrees. We are talking about what? Angles on a straight line, and we said they are supplementary. So if they are supplementary, this angle at B plus this other angle at B should give us 180. We are forming a straight line. ABC is a straight line. So the angles that are on a straight line should give us what? 180 degrees. So that is the consideration of the first property that we have on the straight lines that you're supposed to understand. Then the other property that you're supposed to know, to have an idea about in your syllabus, is that if two lines, let's say A and D, cut each other, that is intersect. We've got a line AB and we've got a line CD. They cut each other, they intersect each other, they cross each other like this. That is to intersect at a certain point. It follows that the vertically opposite angles are equal. That is at vertical opposite angles, it means these angles like this, these are vertically opposite to each other. Vertically opposite like this. So this angle, they are equal. This angle and this angle, they are equal. That is the condition of the vertically opposite angles concept. So it follows that if this is E and this is E1, this is E2, this is E3, this is E4, E1 is equal to E3 at point E. So you consider E1 and E3. They will be equal. So angle E1 will be equal to angle E3. That is, the vertically opposite angles are equal. Also, E2 and E4, they are equal, vertically opposite to each other. There, we've got E2. On this side, we've got E4. So it means E2, angle E2 is equal to angle E4. That is the idea there. That is the concept of the question. That is the concept of the vertically opposite angles. Okay, so you need to understand this. All right, then another property of lines that you need also to understand is that the angles around a point, they add up to 360 degrees. If I have got a point, then I've got lines taken, drawn from this point, whether I've got 20 angles or I've got 10 angles, whatever number of angles that are there. If I add the angles surrounding this point, they should give us 360 degrees. So that is the theorem or the property that we can have when straight lines meet together. We've got this straight line, this straight line. So they meet at a certain point called B. So it follows that B1, B2, B3, B4 added together should give us what? 360 degrees. So that's angle B1 plus angle B2 plus angle B3 plus angle B4 should give us what? 360 degrees. These are angles that are at a point. They add up to 360 degrees. All right, I think this is clear. Then we move on to the concept of the angles that are being generated from the parallel lines. All right, let's talk about this before we consider to say these are corresponding angles or so forth. Considering that we have got two lines that are parallel. All right, or there are three, or there are four, whatever number now of lines that we have. Considering that we've got two lines that are parallel. Parallel lines, they just maintain same distance throughout. The distance here is the same as the distance here, the same as the distance here. So meaning to say these two lines, they will never meet. They will never meet. They maintain equal distance throughout. So that is to be parallel. So if I draw a line that crosses or passes through these two lines that are parallel to each other, this line, it creates a lot of angles, and it has a special name which is referred as transversal. So this is our transversal line or the transverse, just like that. So what this line does, as you can see, it has created a lot of angles that are being created here. We've got this angle. Let us just say this is the point A. This point here, let's say it is the point A, and this point is the point B. So here, let's say we've got 1, 2, 3, 4, and also we've got 1, 2, 3, 4. So we have got 4 angles created at this point. 4 angles created at this point. So meaning to say I've got 8 angles that are created by just drawing this transversal line. This is an angle, this is an angle, this is an angle, this is an angle. 4 angles. Here, there's an angle, there's an angle, there's an angle. 4 angles again. So there are 8 angles that are being created. These angles that we have created, B1, B2, B3, B4, A1, A2, A3, A4, they have properties that you must understand, which should can be taken. Some they use this fan, like this fan. All right. Some they use fans. It's actually fans like this, fans like this. All right. I want us to understand something here. I want us to understand something. These are your parallel lines. So we're going to talk about this in the properties of the shapes, the corresponding, this and that. But just consider this is like parallel. This being parallel, this being parallel, this being parallel, like that. So each and every part of this is going to be explained. All right, going to explain this. All right, so that is where we have these first part, corresponding angles, alternate angles, and so forth and so forth. All right, so on that funds that I indicated there, you will see that the F is for the corresponding angles. All right, we had something like this, remember? Like this. All right, so the F that we see as for the corresponding angles. What are corresponding angles? Remember what I said? Okay, let me just try to draw a little bit bigger F like this. So this is our F for the corresponding angles. The corresponding angles, if these two are parallel, it means that the angle at this point here and the angle at this point here, they are corresponding to it. These are what we call corresponding angles. They form an F. And these corresponding angles, they are equal. So corresponding angles are equal. So the angle at this point and the angle at this point, they will be equal. So whether the F is like this, is drawn down like this, we can have it like this. Whether it's like this, and these two lines are parallel, the idea does not change as long one of the angle is out and the other one is inside. Like one is in, the other one is out. Take note, these are the lines that are parallel. So one is inside of the parallel lines in between, the other one is outside. So it can follow that we can even have it like this, as long we are following the idea there that one should be inside of the parallel lines, one should be outside. These are corresponding, they correspond to each other, they are equal. So this is the explanation that we have here, that this angle, it's going to follow that from these parallel lines that we have, from the first one, is going to follow that the angle at G1 and the angle at H1, they are equal. So here, the angle G1 is equal to angle H1. And the same thing at this point, the angle G2, it corresponds to H2. So these two, they are equal. The same thing, this angle and this angle, this angle and this angle. These are what we refer to as corresponding angles. They form F, all right? They form F. This is the explanation that they just try to illustrate there. We've got an F. So one is inside, the other one is outside. They are referred to as what? Corresponding angles. Okay, let's move on to another one, which are the alternate angles. So alternate angles, they create a Z or N from the funds that we have, all right? The ones that create N like this, or create a Z like this. These are the alternate angles. These are your alternate angles. So it follows that on alternate angles, they are equal. This angle inside and this angle inside, this angle inside, this angle inside, they are equal. So alternate angles are equal, just like corresponding angles. They're equal. So they form a Z, whether it's in this way or it's in this way, whether it's an N in this way or it's another N in this way. As long we have this format, the angle that is inside here and this one, they are equal to each other. So this is what we have. We've got parallel lines. We consider here, gonna create a Z. So it follows that the angle at G1 is equal to the angle at H1. So this is the one that we refer to. The angle G1 is equal to the angle H1. At this point, considering this, again, we can see that we still have a Z, considering this one, still a Z. So this angle at this point and this angle at this point are the same. G1 is equal to H1, okay? Whether it's slanted like this, as long we have our Z, our Z there. We're creating a Z at this point. So this angle G1 is equal to H1. They are alternate to each other. The same thing here. Consider this as our Z like this. So it follows that angle G1 is equal to angle H1. These are what we refer to as what? As alternate angles. So they create a Z or N. Okay, then we have the one that create a U, which is the co-interior angles. So on the front, the one that create a U like this, these are co-interior. So co-interior in which sense? In the manner that, okay, I want you to see what was happening on the corresponding angles, the one that we're creating F. You saw that I was explaining that one of the angles is inside, other one is outside. I was explaining that. But the moment we say co-interior, it means both are inside. There's an angle inside and another one inside. It's no longer a concept that one is in, the other one is outside of the parallel lines. When I'm saying the angle is inside, I'm saying it's covered by these are the parallel lines. It's covered by the parallel lines. It's inside of the parallel, in between the parallel lines. So both angles are inside. That's the co-interior. So these two angles, they are not equal, okay? They are different from alternate angles. Yes, alternate angles, we said they are equal. We talked about the corresponding angles. We said corresponding angles are equal. But for co-interior angles, they are not equal. But what is it that they do? They are supplementary. Co-interior angles, when taken together, they add up to 180 degrees. So these, they add up to 180 degrees. As long your angles are co-interior angles, they should give you 180 degrees. All right. So considering the first diagram, let's say we've got our parallel lines in this case, and considering this part here as our part of the co-interior, as long as we've got the U shape, this one, as you can see here. So it follows that this, if this is G and this is H, let's say this is G1 and this is H1, the angle at G1 and the angle at H1 are the co-interior angles. So these angles, when combined, added together, the angle at G1 and the angle at H1, which is this one that I'm indicating as H, but here it shall be H1. When combined together, they must give us 180 degrees. That is the idea of what? The co-interior angles. They are supplementary. They add up to 180 degrees. So this is the idea here. We've got our co-interior. We form, as long we form this U shape, if we add these angles inside, they must give us what? 180 degrees. So that is the co-interior angles for you. You just have to revise each and every part, right? Understand each and every part. Then we move on. Again, you are supposed to understand the properties of triangles, all right? On your triangles, talk about the acute angled triangles, all right? Acute angled, acute from the word acute. An acute angle, we are talking about an angle that is less than 90 degrees. If A is an acute angle, it is going to be greater than 0 degrees, but less than 90 degrees. So A must be greater than 0, and A must be less than, it is smaller than 90 degrees. So meaning to say this angle and this angle, they are less than 90 degrees. That is what we refer to as an acute angle. An acute angles, all three. But is that possible to have all three angles less than 90 degrees? Is it possible to have a condition where both angles, like let's say this is a 50. Remember, angles in a triangle or interior angles. I mean, not co-interior, but all the interior angles of a triangle, they add up to 180 degrees. As long as we're talking about a triangle, they add up to 180 degrees. So when you're referring to the acute angles, I'm just going to take, for an example, that this is 80 degrees, all right? And this is 50 degrees, and this is also 50 degrees. Does it make sense? Okay. 50 plus 50, that's a 100. If we add this plus this 80, that's 180. All these angles, they are acute angles. So that's an acute angled triangle. All three interior angles are smaller than 90. They are acute. So all these angles inside, they are smaller than 90 degrees. Okay. Then we've got a right angle. A right angle, it means there is now a 90-degree angle. Right angle means there's a 90-degree right angle. Remember the concept of a perpendicular line. A right angle presented with this symbol like this. That is the symbol of a right angle. So the right angle indicates 90 degrees. So that is a right angle triangle. Like this part, we're going to have a 90 degrees like at this point. That's where we can even use our Pythagoras theorem. Remember the Pythagoras theorem, this being our hypotenuse, it follows that the hypotenuse squared, which is this C, is equal to the sum of the shorter side square, which is A and B squared. So it's going to be A squared plus B squared from our Pythagoras theorem. Because it's a right angle triangle, we can talk about that. All right, then we can talk about an obtuse angled triangle whereby there is an obtuse angle. An obtuse angle is now greater than 90. So it's greater than 90 degrees, but being greater than 90, it is less than 360. You know, it's not just greater than 90. Yes, it's greater than 90, but less than 360 degrees. That's what we refer to as an obtuse angle. All right. Actually, to 360 is going to be too much. Less than 180. It must be less than 180. Sorry for that. Less than 180 because remember we've got the straight line at 180. Okay. 360 to be too much. You'll be talking about another angle that is called a reflex angle. So the obtuse is just 90 to 180 degrees. You're done. So yes, we can just say greater than 90 for the understanding, but it is not supposed to exceed. It is not supposed to be more than 180 because at 180 we've got what? A straight line. Okay, so maybe we're going to consider this as our obtuse angle. Or it's just a type of a triangle that you can just know it's there in your syllabus. Don't be scared about that. Then also the type of triangles, considering the properties, because sometimes because of the properties of the shape, they ask you a question based on these properties because they know you know these properties. So that's why I said you need to know the properties of your shape. Okay, so let us talk about a scalene triangle. A scalene triangle is one of the triangles that it is just of its own. No sides are equal, no angles are equal. So nothing is equal, right? The angle at A is different to the angle at C, is different to the angle at what? At B. That's a scalene. In terms of size, the side AB is different to side BC, is different to side AC. They are not the same. That's a scalene. Whereby an isosceles triangle, we've got two sides that will be equal. So the moment we have two sides are equal and the angles opposite the equal sides are equal, that is the theorem now that follows to say, if these two sides are equal, the angles that are opposite to say this side opposite, like it faces like this is opposite. So you're talking about B, this side opposite angle C. So the opposite angles, which is the angle at B, and the opposite angle here, which is the angle at C, they are also equal. So it means the angle that I see at B is equal to this angle that I see at C. Because AB is equal to BC. So the indication of these lines show that the lines are equal. Okay, if I indicate a line like this, so if I indicate, I can indicate one, I can indicate two lines, it's up to you. All right, so it follows that sides opposite equal angles, they are supposed to be equal, or it can be angles equal opposite sides, they are supposed to be equal. So if angle B is equal to angle C, it follows that the sides that are opposite these angles, these two sides, should be equal. Or if the sides are the ones that you're given, the angles opposite those sides should be equal. So they can give you any consideration. You're supposed to know this. What I'm trying to say is that they can give you like this. If you are given that this is triangle ABC, and you are given that angle B is equal to angle A. So from the angles, it follows that the opposite sides will be equal. So angle A is opposite to side BC. So the side BC must be equal to angle B is opposite to side AC. So it must be equal to the side AC. So it's an isosceles. This side and this side are equal. If it was a consideration that it is this angle and this angle that are equal, so it follows that the opposite side are equal. So this side, this angle, it corresponds, it is opposite to AB. So AB, this angle A is opposite to side BC. So it follows that AB will be equal to BC. So it is about where you are given the condition. So like I said, they can give you as angles, or they can give you as sides. If you are told that AB is equal to BC, what does it mean? It means the angles that are opposite to this side. So BC, it's opposite where? It's opposite to A. What about AB? It's opposite to where? It's opposite to C. So it follows that the angle at A and the angle at C, they are equal. They will be equal automatically. So A will be equal to C. Just because these two sides are equal, you just have to locate the opposite what? The opposite angles. By doing so, you have your condition. You have the properties of what? An isosceles triangle. Once you understand this, guys, you can answer any question about an isosceles triangle, and they do ask this. They do ask this. We shall see as we are doing question papers. Please do recall this because I said it. They do ask this property. You are supposed to know this property by heart. This part that I'm explaining here. All right, let's move on to the equilateral triangle. The equilateral triangle is not much special here because they just know that you're gonna know this because equilateral, everything is equal on an equilateral, everything. All the sides are equal, so we're gonna have all sides equal and all the angles are equal. So since we said angles in a triangle add up to 180 degrees, this is what we said. Angles in a triangle, they add up to 180 degrees. And we are saying equilateral, everything is equal. So we've got three angles that are equal. The angles in a triangle, there are three. So if we divide 180 degrees by 3, we are going to obtain 60 degrees. So it means this angle is going to be 60, this is going to be 60, this is going to be 60. So these are the properties of what? An equilateral triangle. Then another property of the triangles, it does not follow to say it's an equilateral triangle or it's a what? This follows to any triangle that you are given. All right. It's a relationship that happens on a triangle to say that, or any shape, as long it's a closed figure, any polygon. If I extend one of these lines, if I produce one of these lines, like I just extend this line like this, what happens is that I create two angles on this line. One which is inside of the triangle, and another one that is outside of the triangle. This is out of the triangle. So the angle that is out of the triangle is referred to as the exterior or the external angle. This is the exterior or external angle. Then the angle that is inside of the shape, this one, is referred to as the interior because we said it's inside of the shape, inside of the triangle. So it's referred to as the interior or the internal angle. Interior or internal. So what happens is that, remember, the condition that we want is for us to relate to the angles inside of the triangle. This angle that we refer as the interior angle, it has angles that are corresponding opposite to this angle and this angle. They are opposite to the interior angle. So this exterior angle is equal to the sum of these two angles in the opposite. This angle in the opposite and this angle in the opposite. The exterior angle will be equal to these two, the sum of these two angles. So this is what we have here. Considering that this is our triangle ABC, our normal triangle ABC, the moment that we extend or we produce the line BC like this, it means we now have the interior exterior angle concept. So the angle C2, because we've got C1 and C2, which is considering ACD, that's our C1, then ACB, which is our C2. There are two angles here. One that is outside is our exterior angle. The one that is inside is our interior angle. But we are not worried about this. We are worried about the angles that are opposite. That is the angle at A and the angle at B. The ones that are opposite are the ones that I'm talking about here. The ones that are opposite to the interior angle. Those are the ones that you need to know. So it follows that this exterior angle, which is the angle at C, which is C1, C1 is equal to the sum of these two opposite interior, which is angle A and angle B. So what does this part mean? The exterior angle is equal to the sum. The exterior angle, this one, is equal to the sum of the what? Opposite interior. So we can say in short, the exterior angle is equal to the sum, is equal to the sum. The sum means you're adding these two, all right? The sum of the opposite, the sum of the opposite interior angles, the sum of the opposite interior angles. All right, so that is the condition that you are supposed to understand. As we can see, the interior angles opposite are these two angles. These are the ones that are opposite to the interior angle. This is the interior angle, C2, but we want the ones that are opposite to that, all right? So that is how we play around with this type of a question. I just hope you are going to revise as much questions as you can. All right, then we've got the case of congruency. That is also part of a syllabus. They need you to understand the case of congruence, which happens in triangles. So we've got the 4 cases of congruency that are very, very important in your syllabus. All right. When two triangles are congruent means it's exactly the same. Exactly the same. It's like you buy a new pen, all right? You buy a new pen, same brand, okay? You buy 2 of them, right? 2 of them, same brand, and you just misplace that pen. whether you have it as new as what, but the moment that pen is being misplaced, it's difficult for you to recognize that it's yours because it is identical to another pen, the same as another pen, unless there's a mark that is there or something that you can use to say to differentiate. So congruent figures, these are identical. All right. Identical figures, identical triangles. Okay, let's just talk about triangles. Identical triangles. Let's consider that because we've got similar figures, the one that we talked about in our grade 9. Similar figures, it's like you, it's like I'm gonna give an example of you as a person and your image. Just take a photo of yourself, the image of yourself or the photo of yourself. That's a similar figure. It's similar to you. You see, you are it's a similar figure. You are not of the same size as what you see on the photo. It's just similar. You see, this is myself. That is being similar. But identical, we are saying these are similar triangles, identical. So identical means everything is equal. If you consider this triangle and this triangle, everything, the size is supposed to be the same. The size of this triangle and the size of this triangle is supposed to be the same. It's not going to be a condition of similar figures where we can have a smaller triangle and we can even have a bigger triangle. No. On congruent figures, they are going to be of the same size. That is what I'm trying to say when I'm saying they are identical triangles, congruent, same. All right. So the conditions of congruence that we have, the first one is the one that we are given here, whereby we are given all the sides. If you see a shape where all sides, you're given two triangles, all right? The first triangle and the second triangle. You see that the sides on the first triangle, this side, all right, this side and this side, this side and this side, this side and this side, they are the same on both triangles. It's a condition for you to say, for you to conclude that these two triangles, they are congruent. So it's called side, side, side. So it's a condition. Once you see that those two triangles, they are congruent. Or for you to see that the two triangles are congruent, it can be a condition whereby you are given this a side, which is the same from one triangle to another. Then there's an angle that is inside of the triangle, same as another angle again, that is on the other side. So it's a condition whereby the angle is being included, and this is called side. So you're going to consider this side and this side. So it's the side. Then you move on to the angle, which is this angle and this angle, then to the side. So it's called side angle side. Side angle side. Okay? Then we move on to a condition of this nature, whereby two triangles are congruent if two angles and one side are equal. Once you see this, you just say this angle here and this angle, they are equal. This angle and this angle are equal. This side and this side are equal. The moment you see that, there is no way the whole triangle is going to be a congruent triangle. The whole of the triangle. So this is what we can refer to as angle, side, angle. So this is angle, side, angle. This angle and this angle, we move on to this side, we move on to the angle. So that is the condition, angle, side, angle. So some, they call this side angle, angle, side angle, angle. Some, they call it angle, angle, side. Okay? Just way of illustrating. All right, then condition number 4 is of the right angle hypotenuse side. Whenever you're given a right angle triangle, the condition is going to be a right angle hypotenuse side. That is RH, right angle hypotenuse side. Right angle hypotenuse side. So once you see a right angle triangle and another right angle triangle and this condition, then they ask you the condition there is going to be right angle hypotenuse side. So it's a, once you see that, they will be congruent to each other. So like I say, similar figures are different from the similar triangles are different from congruent. And also, okay, before you talk about similar, the sign for congruent, because we shall talk about this when you are saying maybe another triangle is maybe triangle ABC, or what is congruent to another triangle, maybe it's triangle ABC congruent to, this will be the sign is congruent to. So you're going to have three horizontal lines equal. These lines here, they're supposed to be equal in length, three of them. Okay, so it's congruent to another triangle. Maybe it's I don't know, maybe it's AFG, whatever that you're given, but the sign for congruent to is that one. Okay, and we shall talk about this. And also, this is what I want you to understand on congruent figures. On congruent, it's very, very important before we talk about similar figures. Yes, now you know the condition. If two triangles are congruent, it follows that if two triangles are congruent, I'm just gonna try to write fast because of time. All right, let's see. If two triangles are congruent, so let's consider a condition of two triangles. Here I'm just giving an example. I'm not saying these two triangles, they are congruent, right? Let's just say these two triangles, they are congruent to each other. Triangle EFG. Okay, this is what we have. We've got two triangles. We located that they are congruent, and this is maybe what you ended up with. Therefore, it follows that the side, because we are talking about two triangles that are identical to each other. So it follows that the side AB, this side AB, this will be equal to, all right? So it follows that AB will be equal to EF, corresponding from A to B, E to F. So it will be equal to side EF. Please be careful. Okay, let's move on. BE, from B to E, from F to G, B to E. Take note, BE from the mid to the end, from the mid to the end. So it follows that BE is going to be equal to FG. Okay, then the last one, A to E, this side, from A to E, from E to F, the first to the last, the first to the last. So it follows that AB, which is the first to the last, AE is going to be equal to EG, the first to the last, which is EG, like this. This is the condition that you are supposed to know about sides. The sides that you be given, they will be exactly equal, exactly equal, exactly the same, exactly equal. If the two triangles are congruent to each other. Okay, I just hope you understand what I'm trying to say. Then the last part that we have is of the similar figures on this introduction. The similar figures are not like the congruent figures. The congruent figures, like I said, they are exactly identical. Then the similar figures, I gave an example of you and your image. Okay, if you take yourself a photo, you are similar to, the photo is similar to you. You are the original, okay? So you and your photo, you are not congruent. in actual sense, you do not have a congruent figure to you. It does not exist, because congruent figures, they are identical. There's nothing that you see from one that is different from another in terms of size, in terms of angles. Your photo, it is reduced in terms of size, right? And it can't be like it's an image, guys. Okay, so it's a similar figure to you. So that's why I was explaining that the triangle can be even bigger, the object, and the smaller triangle as your image, as long the angles that are inside of the triangles are equal. It's on the angles. It's possible that two triangles can have equal angles, but being of different size in terms of the shape. As you can see, I've got two triangles, A, B, C, and another triangle here. They are of different, look, this one is big, this one is very small. But the angles does not stop us, are not limited. The angles are not limited for not to be equal, because the two triangles are not of the same size, like in terms of the shape. We can have a bigger shape and a smaller shape, but angles taken to be equal. It's very, very possible. So as we can see, the angle at A is equal to the angle at D. The angle at B is the same as the angle at E. The angle at C is the angle at F. So we are simply saying similar figures are equiangular in short, because of the angles that are the same inside of the shape. So this is the statement. If two triangles are similar, that is, they are equiangular, then their corresponding sides are in the same proportion. What are we trying to say here? We are simply saying the ratio of sides is the same from this statement. The ratio of sides, the ratio of sides, is the same. So when you're talking about the ratio of sides, it is a ratio that is created from similar figures. All right. How do I create similar figures? Okay, this is it. For you to create the similar figures, we've got two triangles. The first triangle is up to you. It's a choice. Let's say I want to take my first triangle as ABC. This is my first triangle, ABC. I just took the angles ABC from the angles that I'm given. All right. We talked about the sign for congruent to like this. This is the congruent to, and the similar to is just opposite, just vertically up. So this sign is for similar to. So triangle ABC is similar to the triangle. The next triangle is determined from the first triangle that you have listed, that you have mentioned. So you mention or you write this triangle according to how the angles are given. All right, let's start. Angle A is equal to angle D. Angle A and angle D. So this will be a D. Angle A is equal to angle D. Okay, because we're talking about equiangular. B, move on to angle B and angle E. So angle B is equal to angle E. Then C and F, angle C and F. So this is C, this is going to be F. That's how you take your similar figures. You don't just take randomly A, B, C, then another one you just say D, F, E. No, you take the second one from the first one, from the angles A is the same as D, B is the same as E, angle C is the same as angle F. That's how you write or you take your similar figures. But it does not follow that AB is equal to DE. Here it does not follow, does not know. They are not equal. It was just on congruent figures. That's where I said, if these two figures are congruent, therefore the sides that are corresponding from the congruent figures AB is equal to EF. DE is equal to FG. AE is equal to EAG for congruent figures. But if two figures are similar, all right, let's say we've got these two ones which are similar. We say it is not the sides that are equal, but what is equal is the ratio of sides. Then their corresponding sides are in the same proportion, in the same ratio. So we're going to have the same ratio from these similar figures. It then follows that, therefore, it follows that the ratio of sides, okay, this is how you take a ratio of sides, AB, all right, it corresponds to DE. So this is how we take it. So this is AB over DE, first and last, AB over DE. Take note, when there was a congruent here, if it was a congruent, if it was like this, triangle ABC is congruent to triangle DEF. We said AB is equal, not to say there it's a ratio, they will be equal like this for congruent. But for similar figures, you consider the ratio AB over this, okay? Once you get a ratio, once this AB over DE gives you a 1, it means those figures, they are congruent, they are not similar, all right? Then we move on, is equal to, remember we started the first and last, first and second, then we're going to move from the second term to the third term, the second term to the third term. So it is going to be BC over the corresponding here, which is EF. All right, is equal to, there's another one left, which is from A to C. You take this from A to C, from D to F, the first to the last, first to the last. So the first to the last, that's AC. So this will be AC over the first to the last, which is going to be DF. That's how you write this ratio. So it follows that once these two triangles are similar to each other, the ratio of sides is equal. But if these two triangles are congruent to each other, the corresponding sides are equal. AB will be equal to EF and so on and so on. So that's the difference between similar figures and congruent figures. For similar figures, they want you to take this idea of what the ratio of sides. Do you know how to apply the ratio of sides? They want you to know this. They want you to understand this. Okay, so these are the questions that we have here. I just want you to work out these questions, all right? This is a revision exercise. Try and work out pertaining or including what we just talked about in detail, or the introduction in detail of what is required for you to understand or to know. So what I want you to do is to work out these questions. Try each and every question that you are given. Try to work them out properly. Try to do as much as you can on these questions. Okay, this is the only part that we have on the questions actual. So just try to do these questions, guys. Then we shall meet again with revisions. But if there is any question that is challenging after this introduction, let me know about that question. But with this introduction that we have, we shall see that there are so many questions that we shall attempt, and what you need is for you to apply each and every information that I explained on this part. You need to know it so that you'll be able to understand all of the questions that we shall be doing from our past exam papers, from the question papers, preparing yourself for the exams which are ahead of time.